Shah, your pose. Shah, okay. Ja, pose. You seem a bit upset. What's wrong?
I'm so upset right now, Shah. I'm scared. What if I can pass this exam like I did last semester?
No, don't be scared. Because if you're scared, then I'm scared too.
Shah, I think you are quite confident on our chapter 2. Can you really explain to me or to us about the differentiation?
Differentiation?
Yes.
Sure, that's easy enough. So basically, what it means is differentiation is the process of finding a derivative. So the derivative, to find that, you have to investigate the limit h approaching to 0, and so which is also known as the slope of the curve. Aside from that, I don't really remember much. I think I know what you're trying to say.
Well, to further illustrate it to you guys, the definition of derivatives can be found by solving the limit h approaching 0, f at x plus h minus f at x, and over it all by h. Isn't that correct, Ainnur?
That's correct, Shah.
Do you still remember the techniques of differentiation?
Of course. Those are the derivatives of sums and differences, and then the product rule, the quotient rule, the chain rule, and also the implicit rule. But before we proceed with those techniques, I think I need to show you guys the derivatives of constant, linear, and power functions. Before all of that, we need to master the derivatives of constant, linear, and also the power functions. So, first, the constant functions. So, the derivatives of constant functions are always 0. Next, we got the linear functions. The derivatives of linear functions are the coefficient of x. The next, the last but not least, we got the power functions. The derivatives of power functions are like this. I think that's all.
Oh, about the derivative of the sums and differences rule, actually, I know a little bit about it. It's basically when you have two functions that are either added together or subtracted. And so how you solve that is by separating two functions and then differentiating them separately before combining the two and retaining the same operation. You understand?
Yes.
I can explain about product rule too. They only apply on questions when terms are multiplying each other. All we need to do is identify each term as u and v, then differentiate them separately to use in the formula uv prime plus vu prime.
Now I think I can explain to you guys the quotient rule. The quotient rule is a method used to find the derivatives of a function in the form of ratio or division. So just like the product rule explained by Ziegler earlier, by identifying the terms of the equation, we can find the derivatives by using the formula dy over dx is equal to vu prime minus uv prime and over it all by v squared.
Wait a minute, why is this my first time hearing this? I don't understand. You'll get it in, right? You'll get it in within time, soon, maybe, I don't know. But clearly you won't get it today. That's it, I give up.
What do you mean?
Differentiation itself is hard. Then they want me to settle both differentiation and trigonometry. I'd rather skip. My man, it's not that hard. Even I know can do it.
Yeah, of course. Wait, was that insult?
Yes.
Even if it is, I don't care. But let's show you how to solve it.
Oh my god.
For question A, let's tackle this question together. So, as we look into the question, the first step is we need to identify the terms as u and v. 3x squared will be the u and zx plus 2 will be v. And since we are looking for dy over dx, we also require to find the u prime and v prime value of the equation. So our u prime will be 6x and v prime will be sec x plus 2 tan x plus 2. And next, we can move to the next step and we will be using product rule equation, which is dy over dx is equal to uv prime plus vu prime. And last but not least, we just plug everything into the formula and boom, we've got the answer. So, for question B, the step is similar to question A, but a bit different in terms of the formula used to answer this question. As we did before, we need to identify the terms as u and v and simultaneously determine the value of u prime and v prime. Based on the equation given, 4x plus 2 will be our u and cos x will be our v. And our u prime will be 4 and v prime will be minus sine x. This time, we are using the quotient rule formula. Dy over dx is equal to vu prime minus uv prime and over it all with v squared. And finally, substitute all the value we had identified earlier into the formula and that's it. Now, that's how we solve it like a pro.
Guys, do you recall how to do the implicit differentiation?
Not really. I do remember it's quite complicated though. You guys really don't remember this?
No.
It's very easy.
Okay, do you mind explaining it to us if you're that good?
Well, if you want me to, I don't mind. Okay, so first,
Given y ln 3x minus exponent 2x plus 1 minus tan 4y equals to 0, find the dy dx using implicit differentiation. You have to determine the terms of the question. For example, y ln 3x is our first term, negative exponent 2x plus 1 is our second term, and negative tan 4y is our third term. By using the differences rule, you can differentiate all three terms separately before combining them all together, retaining the original operations. Then, you can rearrange everything, separate dy dx to one side and factorize. After that, you can bring ln 3x minus 4x by the power of 2, 4y, to the other side. And that's how you get the answer.
By the way guys, I know you didn't ask this, but let me show you how I solved linear approximation question. I think I have a cheat code on how to get a full mark on this.
Yes, why not? It could be a revision done for us too.
Okay, so basically, this is the question. Right after seeing a linear approximation question, all you have to do is classify this as our fx, then find the same number in the equation given. This will be our x as the given value. Now remember, we need to also find x node, in which is the closest value to our x. In this case, x is 80.99, so our x node is 81. While we're at it, we need to find delta x, which is the difference between x and x node. Just minus the value of x to the value of x node. Now, we recall the formula. To do so, we need to find the derivative of fx. Then, you can start finding the overall derivatives by substituting x node, and you're done!
Wait, you guys are not impressed?
we learned this yesterday.
I thought you said we are allergic.
As a conclusion, differentiation stands as a cornerstone of calculus, offering profound insights into the behavior and rates of change within mathematical functions and real-world systems. Understanding differentiation well and practicing it can help people solve difficult problems and come up with new ideas in many different areas. That's all from us. Thank you for watching.